Hi there. In this video, we are going to do a Riemann sum practice. So we want to estimate the integral from -1 to 3 of x cubed minus 2x squared plus 6 dx to 3 decimal places by using a right-hand Riemann sum with 4 subdivisions. And then we want to figure out how far was the exact value from our actual estimate. So we're going to do two things. We're going to estimate it using the Riemann sums, then we're going to actually integrate it, and then we'll find the difference between them. With each of these Riemann sum problems, a really good first step is to graph it. First, graph it. And after you graph it, then you can cut it into your subdivisions. And that just really helps me to be able to visualize it. And so here is our graph. So we've got our graph here, and specifically you want to make sure you graph from -1 to 3. And then I made sure to show what each of these ordered pairs are, because those ordered pairs are important for making our subdivisions. So right-hand Riemann sum, what that means is you're going to make a rectangle. You're going to make a rectangle here using the right-hand corner as the top. And so I'm going to go ahead and just cut this into 4 equal parts, and then we'll go from there. So we have 1, 2, 3, 4. And now the right-hand piece of it means take the right upper corner and make a rectangle. So this would be the right upper corner from this subdivision here. And so I'm going to go straight across this way and make my rectangle. There's my rectangle. I'm going to go from here and I'm going to make my rectangle because this would be the right upper corner. There's my rectangle. And some of these rectangles you're going to see are going to be an overestimate. This one would be an overestimate because it goes above the line. This one would be an underestimate because it goes below the line. So our next rectangle, this is going to be the right upper corner, and so I'm going to go ahead and draw a rectangle. And lastly, I'm going to draw my rectangle. There are multiple types of Riemann sums. You could do a Riemann sum from the left upper corner, or you could do a midpoint one, but this one specifically says right. So now to estimate this, we want to find the area of each of these rectangles. So the area of the rectangle is going to be the length times the width. Well, here's our width here, and that distance from -1 to 0 is 1. Here is our length or our height, and that distance is from 0 to 6, and so this would be 6. Well, 1 times 6 is 6. The area of this rectangle is 6. Okay, we'll do it again with the next rectangle. This here is 1, and this height here is 5. 1 times 5 is 5, and I got that from this ordered pair here. It is at 5. That's the height. This is 1, and this is 6. So there's 6. This is 1, and this is 15. And now what we need to do is we need to add those all up. So we're going to add them up to get what our estimate is. And so we have 6 plus 5 plus 6 plus 15, and we get an estimate of 32. That's the estimate. So the first part of this was estimate using 4 subdivisions. We graphed it, and we took that graph and we broke it into 4 equal rectangles. After we broke it into the 4 equal rectangles, we found the area of each of the rectangles, and then we added them up to get this estimate of 32. The second piece of this says how far from the exact value is your estimate. To find the exact value, you need to integrate. And so we're going to integrate from -1 to 3 of x cubed minus 2x squared plus 6 dx. This one is a power rule integration, and so you're going to increase your exponent by 1 and then divide by that new exponent. So this can become 1/4 x to the 4th. Increase, so this is going to be to the 3rd power now, which means we're going to have negative 2/3 x to the 3rd power. Increase, so we're going to have plus 6x. And normally we would say plus c at the end, but because we have an upper and lower bound, we'll put this in the square bracket and we'll say from -1 to 3. Now what we do is we plug in our upper bound and then we subtract that value from our lower bound. And so we are going to have 1/4 times 3 to the 4th power minus 2/3 times 3 to the 3rd power plus 6 times 3. And let's go ahead and put that in a big set of parentheses, and then we'll subtract our lower bound. 1/4 times -1 to the 4th minus 2/3 times -1 cubed plus 6 times -1. Let's go ahead and plug that into the calculator. I'm going to plug it in on a different screen here real quick just so that I can see the work I'm supposed to be plugging in. Okay, and so when we have this all plugged in, so I did the first piece first, and I got 21 or 20.25, and then I did the second piece and I got -5.03, and then I subtracted, I subtracted these from each other. That's what I did. But a double negative makes a positive. I get 25 and a third. So we get 25 and a third here. And that's what the actual value is. So the actual value is 25 and a third. To find how far from the exact value is your estimate, you would take 32 and you would minus 25 and a third. You'd subtract 25 and a third, and we're going to get 6 2/3. That's how far off our estimate was from the exact value. So that's how far off our estimate was from the exact value. So we've got two answers here. We have our estimate, and then we have the error. This is the error.